Hey everyone, this is part 2 of our section 2.1 chapter, which we're going to talk about sigma notation. So it's a continuation of sequences and summation notation. So sigma notation. So sigma is this symbol. So just like sequences, they represent terms. And in this case, we're going from k equals 0 to k equals 4. So if I'm just looking at the terms of the 3 to the k sequence, right, this will be 3 to the 0 will be the first term, then 3 to the 1, 3 squared, and there's a reason I'm leaving a space here instead of using a comma. 3 cubed, and then 3 to the 4th. This says start at 0 and end at 4. So I start at 0 and I end at 4. Now if I tell you that the sigma means summation, what operation does that mean? So summation means we're going to use addition. So as soon as I see sigma notation, that means I'm adding the terms of the sequence being given here. So I'm going to have 3 to the 0, then plus 3 to the 1, plus 3 to the 2, plus 3 to the 3, plus 3 to the 4. And so that will be so that's what sigma notation does. It tells you that you're going to add the terms of the sequence. So the 3 to the k is still a sequence, but now we're going to add up the terms. So 3 to the 0 is 1, plus 3 squared is 9, plus 3 cubed is 27, plus 3 to the 4th, that's 81. And so we can add that up, and when you add them, what do we get? So when we do them on the calculator, we get, this is 121. And so that will be the summation. So if it had said from k equals 0 to 5, then you go one more term. So let's try another example. So say I want you to find the summation k equals 1 to 3 of, now my sequence is changing, 2k plus 5. So oftentimes you'll see a general summation, something like k equals something, so 0 to n of a sub k. And so this is telling you start at 0 and go all the way to n. So this is going to be a sub 0 plus a sub 1 plus a sub 2 plus, depending on n is a sub n. And so this is a general summation notation. And you can also go to infinity, but we're going to talk about that in future sections. So here, starting with k is equal to 1. So this is going to look like 2 times 1 plus 5. So that's my first term. And then the sigma means I'm going to add them. So plus, then when k is 2. 2 times 2 plus 5. Plus, so that's my second term. And now the third term, 2 times 3 plus 5. Do I keep going? No, right? This says start at 1 and end at 3. So that's as far as I'm going to go. And just simplifying. So 2 times 1 is 2, plus 5, that's 7, plus, that's 4, plus 5 is 9. And 2 times 3 is 6, plus 5, that's 11. So what do I get when we do that? So 11 plus 9 is 20. So I get 27 would be the sum. And let's try another one. So what about, let's say k equals 0 to 5 of k factorial. So it's not an exclamation point. Well, it is an exclamation symbol, but in this case, it means factorial. So k factorial. So what does that mean? What is it? You notice that we start at 0. What? So k factorial is defined to be the product of k and all the numbers that precede it. So k factorial is essentially k times k minus 1 times k minus 2, k minus 3, and so on. All the way 3 times 2 times 1. And I know that you may be like, what is that? So let's do an actual example. So for example, if I say 5 factorial, then 5 factorial means I'm going to start with 5, right? 5 and then the one before it. So 5 times 4 times 3 times 2 times 1. So that will be 5 factorial. And then you can do the math here. So 5 times 4 is 20, times 3 60 times 2 is 120. So 5 factorial is 120. 3 factorial will then be 3 times 2 times 1, which is 6. And I can just keep getting, we can make it bigger, right? So I can, what if I say 9 factorial? What does 9 factorial mean then? 9 factorial will be 9 times 8 times 7 times 6 times 4 times 3 times 2 times 1. And I'm not going to compute that one out, but that's what a factorial means. So if you had 30 factorial, that would be really hard to write out, right? 30 times 29 times 28, all the way times 3 times 2 times 1. And so in this case, when I see from k equals 0 to 5 factorial, oh, so then what's 0 factorial? So something to pay attention. 0 factorial, by definition, is 1. So this is something to keep in mind. And 1 factorial is also 1. So those are the only ones that are the same. So 1 factorial is 1, 0 factorial is defined to be 1. And so back to this example. So if I want to do this summation, I'm going to write it down here. So it'll be 0 factorial. Remember, the sigma means summation, so that means we're going to add them, plus 1 factorial, plus 2 factorial, and so on. 3 factorial, 4 factorial, 5 factorial, and I stop there because it tells me to go just to 5. And I'm adding them. And then just do the factorials out. And if you have a scientific calculator, will have the factorial in there. So 0 factorial is 1, 1 factorial is 1. So you have 1 plus 1 plus 2 factorial, that's 2 times 1, right? So 2 factorial is 2 times 1, so it's just 2, plus 3 factorial. 3 factorial, we get it here, 3 times 2 times 1, so it's 6, plus 4 factorial. So 4 factorial is 4 times 3 times 2 times 1. So what's that? 4 times 3 is 12, times 2 is 24, times 1, 24, plus 5 factorial. 5 factorial, we get it here. So 5 is 120. And then you add these up. So whatever you get when you add these up, you can put in your calculator real quick and get 154. And so that will be the final answer. The factorial is in your calculator. If you're using a graphing calculator, then it will be under the math menu. But for this class, you require a scientific calculator. So in the scientific calculator, you're going to have it on the probability menu. So if you have one of those TI-30X2S, it will be right next to the log button. So the log button is right underneath the second function button, and then next to the log button, you have the probability button. So when you click on that, it will give you the options, and then you'll see the factorial in there. So it will give you a menu option, and you'll be able to see the factorial. So just with sequences, right, we went backwards on sequences. So how do we go backwards on summation? So if we're asked to write as a summation with sigma notation. So sigma is that Greek letter, the capital Greek letter. So what if I have, say, 1/3 plus 1/4 plus 1/5 plus 1/6 plus 1/7 plus all the way to 1/63. So how do you write that using sigma notation? Well, then I'm going to say this is the summation, and it looks like it goes 3, 4, 5, 6, 7. So this one is not too bad. So it'll be 1/k. And where does k start? Well, one way to say is k starts at 3, and it ends then at 63. And that's it. But usually with summation, with sigma notation, we want to start at 0. So if you start it at 0, then this will be k equals 0 to where? And what would it look like? So if k starts at 0, how do you get 3? So it will be 0 plus 3, right? So it will be k plus 3. So since you want it at 63, that means that you have to end at 60. So that 60 plus 3 gives you 63. We could also do it by starting at 1. Right? So I can say k equals 1 to where? So now this will be 1 over, if you start at 1, what do you need to get 3 there? 1 plus 2. So it looks like k plus 2. And then to end at 63, so we would need to end at 61. So that 61 plus 2 gives you 63. So these are the different ways that you could write the same summation with sigma notation. Sequences, you're supposed to start at n equals 1, but with sigma notation, you can really start anywhere. So the answers for these may vary. Okay, email me if you have any questions.